All right, and we are on to cold storage pool discussion. This one's going to be a friend of ours now at HGST, Roger Weeks. Roger, if you want to give a rundown of what you had in the blueprint there, you might
Sure.
also want to turn your volume down because you're getting some echo.
Okay. How's that?
I don't know. How is it?
I can't.
Can you hear me?
Better. I can hear you. I just want to make sure we couldn't hear ourselves. All right,
Okay.
fire away.
Yeah, sorry, I'm on a laptop with no headset. So this is a really high level overview blueprint. So what we wanted to get a discussion going on is what is it going to take for a pool type or other type in Ceph to exist where something can be written and effectively never rebalanced or rewritten, or if it has to happen, very infrequently. So we're talking about, I make the point in here, we talk about cold storage. Think of this as the level above tape, but not actively access data. This isn't something you're spending a lot of time looking at, but it's still data you need to get to a lot faster than you need to get to tape. And we could go into the use cases for that. There are many, but that's the general idea here. Since I'm not a developer, I didn't put anything technical in this detailed description. I was hoping we could get some of that out of this discussion. So that's kind of the 50,000 level view.
Is it possible that we're looking for?
Hey, sorry. Go ahead.
Okay, I'm going to start talking now. Is it possible that what we're looking for is more like an interface where the OSD will notice extremely cold objects and demote them to something that isn't real? Like S3, or a different interface. It could be plugin based to make it somewhat less or more agnostic.
I think the way I read this, at least, is what Roger has in mind is that this would be the pool that you're demoting the really, really cold stuff to.
That's correct.
So imagine a data center full of Ethernet drives, but you're powering them down.
Yeah, that's the part.
You're spinning them down.
I'm not sure how well something like that maps onto the OSD. You know what I mean?
Well, so the thought I had was what right now when the peering process gets going and it's setting up it sets up PG temp mappings to avoid moving stuff just so it can remain available until it has sort of rebalanced data. But what if that logic was policy based? So instead of doing the normal thing in the cold storage pool, it just sets up the PG temp mapping to be where it was, and it doesn't change it until it drops below the desired redundancy, at which point it, inserts a new item that is sort of aligned with the current crush map, but not before that.
Well,
does that make sense?
It does, but we can't do it using the PG temp mapping.
Why is that?
Because anything linear in the number of PGs is not a good thing.
Yeah, I mean, yes and no. I mean, the OST map is linear in the number of PGs and OSDs, right? It's just a small constant. So this is bumping up the constant by something less than 100, hopefully. And maybe that's a price that you pay on your cold storage tier, right? I mean, that ultimately that's the crush is forcing you to one end of the spectrum where you have very little metadata because you calculate it all. But it's only by like a factor of 100. Like literally, you could store every PG mapping explicitly, and it'd be 100 times bigger.
But there could be a thing. I mean, you get almost the same result by just not marking the OSD out, right?
Kind of. You still want the system to wake up and add replicas and move them around when either balance becomes problematic or because you drop below your desired redundancy level.
True.
Right. So there still are reasons when you do want to make things move. You just want to be sort of, instead of like always going all the way to the sort of the moving target of crush, you drag your feet as much as possible.
Is this a write amplification / write stamina problem? Is that what we're talking about fundamentally? Because usually it's not that much. I mean, the whole point of the whatever replication is that it's a whole bunch of OSDs performing a little work to rebalance the data, right?
Yeah, I think it's just still more work than you'd want. Right?
That's
If you have 1,000 disks and you add 20 more, then every OSD is going to wake up and move a little bit of data and then shut down again.
Yeah. Right, and that's kind of what we're trying to avoid here.
But I mean, if you don't rebalance that data at all, then how do you put any new data on the OSDs? I mean, the PG temp doesn't fix that, because then you just don't have anything on the new OSDs.
Yeah, that's true.
I'm still not, because if you add the additional 20 OSDs, unless they're temporary, then either you rebalance the data or you have 20 hot standbys, right?
Yeah. So, I mean, it sounds like for this use case, you pretty much need an explicit object mapping. And maybe there's some clever workaround, but I'm struggling. No, it can't be a PG mapping because you don't want to move the data, which means you can't move any prior PGs.
If you're trying to minimize data movement in the face of disk failures, then you could have a pool of some number of hot standbys. When the monitor detects that an OSD has failed, it cycles one of the hot standbys into that crush position, if not the OSD ID, and that new disk gets logically the same data, right? That's what we're talking about, I think.
Well, I mean, if you read the blueprint, I mean, maybe Roger should start talking again, but he's also interested in stuff
like another option.
Like trying to more efficiently spread or more evenly spread data around and stuff.
Well, yeah, but so the goal is that it's a distributed system in the first place, so you're trying to handle disk failures, right? So when is it that you think the disk might come back and therefore you don't want to waste the work on it, or you just generally don't want to risk reshuffling data because you're only interested in maintaining 100 disks, even if you happen to have 10 extra?
There's some questions coming in on IRC that might be good to roll into this before we let them fall too far behind. Asking if placement groups could be range partitioned rather than hash partitioned. Asking about layering data. I don't know.
So someone explained why range partitioning would be, how that differs, because that's beyond my ken.
I guess he wants them to be so that adjacent key ranges are in the same PG. Is that what you mean?
If you range partition it, you could say that you will never touch the stuff that's written initially. Once it's written, it's filled up, the placement group's filled up, then you move on.
Assuming that the range is the range of things you're talking about is like the object names, like they're named by timestamp or something like that. Yeah. And so because if you're inserting randomly within the range, then which is sort of what happens currently, then it doesn't help.
Right.
I think once you do that though, once you have PG groups that are range partitioned, I assume you mean sort of arbitrary ranges where you can say this PG is a little bit bigger, a little bit smaller, or I want to adjust the range for this specific PG. Is that right?
The advantage of being on a blueprint now, we can make it up. But yes, maybe a well-defined range partition, maybe everything's fixed size, a lot of unknowns right now.
Right. I mean, so if it's a partition that's explicitly specified, which is sort of what I think a lot of systems do, where they say like this partition of the hash range maps to this server and this partition of the hash range or range of the hash range maps, whatever. Then you have metadata for every PG, in which case you're sort of where we started with, where you say this PG is statically mapped to these devices. I think basically the difference is that right now we're partitioning a range of hashes. And sort of what you're suggesting is you would partition based on something else, like the object name, which conceivably you could do. You would have to have per PG metadata that sort of specifies the start and end key for every placement group. But you could do that. I think the challenge is that Yeah, that would be a bad idea though, because you could have, every too many objects that start with foo, and they all pile up in one PG, and suddenly you have to split that, and then the PG splitting becomes totally alienate, non-regular, and yeah, I think that'd be pretty hard. I'm not sure it really buys us anything here. In any case.
It might only work for a small number of devices. When I was at Yahoo, we did some range partitioning on some of our areas.
Yeah.
But let's pretend it's just either a hex range or date stamp, and you're never going to go back again. You can split it.
I see.
Don't know for sure there's a large number of use cases, but I think there's a few of them.
Yeah. Yeah, I think that the trick for me is that right now we don't ever contemplate the idea of moving objects between placement groups, except in the sort of context of a split. And so if we did this, we would have to have, we would probably have to like put restrictions on the way that those splits happen. Like for example, the last PG in a pool is always like some key to the end of the possible key range. So like if all your objects were prefixed by a date, then that last PG would be like the current time to, the infinite future. And then whenever you do a quote unquote PG split, you'd be carving off a PG that's at some boundary within that range. And once it's sort of no longer the end one, it's sort of fixed for all time, which I think captures the use case you're talking about. And would conceivably, I think, fit into the framework, but it'd be tricky. But again, I think it's sort of a little bit different than what we're talking about here. It seems like the thing, the sort of the general motivation for what Roger's talking about is wanting to have devices powered off so that when you add new stuff, you're not sort of shuffling data to rebalance.
Yeah, or if they're not powered off, they're devices where the overhead of doing the rewrites from rebalancing is sufficient that we don't want to do it on that box.
And the general problem with that is if you have sort of one big pool where if you ever need to expand the pool, then you don't want to not rebalance. You do want to rebalance because otherwise all the new stuff is empty. And you need some separation within the new category in order to get the like separation between racks and replication and so forth for the durability and redundancy you're looking for.
Actually,
yeah, I know in some ways this is actually kind of diametrically opposed to how Ceph is designed, so that's why I wanted to talk about it and see if it even makes sense.
But if that's actually what you do want, then I think what you actually want to do is just when you add like your next 3 racks of cold storage, you just create a new pool that's just those 3 racks, and you fill it up. And when it's full, then you turn off the spigot, and then deploy your next 3 racks, and you fill those up.
Right. So when you deploy, you have a pool. Yeah. When you deploy, you have a pool. You fill it up. You don't add anything to it.
Fixed size pools. Yeah, exactly.
Hang on. The goal, though, when you're adding stuff to these cold pools, what I've seen is that because you don't plan on reading back any of these objects anytime soon, you actually just want to write to wherever you wrote the last thing. Right. That's the biggest thing, because you want to wake up whatever is already awake. You don't want to wake up random stuff in the past. That pretty much completely rules out any kind of hash-based placement. Am I correct so far, Roger?
Pretty much, yeah.
With the one pool per rack thing, you're waking up the rack you just woke up, but it's still possibly a larger unit than you really want to wake up, right? So that's where the range partitioning comes in. That's why you're talking. Yeah. That's going to be really strange to put into a software.
Yeah, it's at the end of the day, it comes down to how much metadata you're going to spend to find the data. Because if you have sort of infinite metadata that you're willing to spend to locate stuff, then just wake up 3 disks at a time, write this like stream of stuff to 3 of them until they fill up, and then go on to the next 3, and carefully choose them, and you just have this huge database that says where everything is.
Well, not necessarily.
But you get exactly the right pattern you want. Whereas if you
basically we're creating an index then, which Ceph doesn't have today, right?
If you do have control over the key space, and if you're doing range partitioning, it sounds like you do, then you can still use cross to locate the PGs, right? You're just changing the way objects map onto PGs, and you're making the number of PGs very dynamic.
Yeah.
Right. So that all fits in okay to the OST. The part that doesn't fit in is that the OSDs are constantly looking to maintain balance, and that means they don't want to go to sleep. That's the part I'm not sure about.
Right.
I think so. Yes and no. I mean, I think that the simplest thing. This is sort of shifting topics to like spinning down disks, but the simplest way to implement spin down would be that the OSD stays awake and the little ARM thing on the like Ethernet drive stays awake, but the platter spins down. So you like power off most of the drive, but it's still awake and pinging and says, "I'm alive. I'm just spun down." Versus sort of the next layer where you like literally power off the whole disk and you tell Ceph like this is a weird hook that like does a power on Ethernet and pokes the rack to turn it on or whatever, which I think would be more work to get you sort of that extra level of power savings. But I think if you're thinking about the first one, then
to do that, the OSDs need to be able to defer persisting things like OST maps until a client request actually forces them to do so.
Yeah. Well, I think probably these ones would have would have like a very small amount of flash or something where they can like buffer some metadata or something.
Right. And not to put too fine a point on this, but I also kept this blueprint high level because there are other technologies that we're interested in here that we can't talk about yet because they haven't been announced. So I wanted to see if there was something that could work across multiple types of cold storage. And
that's
unfortunately all I can say at the moment, but
that's why I'm thinking that some kind of plugin architecture that's capable of taking the information that comes out of Scrub and our hitset stuff and offloads the data to something that isn't necessarily Ceph might be an interesting direction.
So basically a plugin that generates an index to do what Sage was talking about?
So it's currently when we do a flush, we flush to a Rados pool, but we don't necessarily have to, right?
So I mean, I think what you're going towards, Sam, is sort of the other tiering blueprint, the cold tier blueprint, where basically the object becomes a symlink that just says over there, it's stored over there, and that the way we contemplated before was another Rados pool, but it could be a tape at offset, tape number 37.
Well, with the Rados pool, we can be a little cleverer, but I think there is actually some mileage to be something to get out of being.
One of the motivations I had reading this was looking at the cache tiering that you guys added recently, and wondering, okay, well, there's this 2-layer tier now, and looking at the architecture, I'm not even sure if it's possible, but could it be made a 3-level tier, to where you've got basically hot data, warm data, and cold data?
Sure.
That's kind of what we are. Yes, that's what we had originally contemplated. So you have the base tier, the cache tier, which has the hot stuff, the base tier, which it flushes to, and then when stuff gets really, really cold, it gets punted off somewhere else. And there's like a pointer that says, go look over there.
Right.
So it's like a symlink that could be into another Rados pool. It could be into a totally different storage system. It could be onto like a tape, archive or something like that.
Okay. So let's say the drive had an API. Let's say the drive had an API exposed for a key value store. Could it be put there?
That's a different problem, actually. That's also straightforward.
Okay.
Yeah.
The way the OSD talks to its storage is abstracted, and we actually have a couple of backends that are capable of speaking key value storage.
Doing key value.
Right.
So I think going back to the beginning.
Okay.
I think you have these extremes. You have the extreme where you have this huge index that says exactly where every object is, and you get to decide exactly where it goes, and you carefully choose the drives that are already powered up, something like that. Versus where Ceph is, where it's like, I don't want to store any metadata, so I'm going to calculate everything on the fly and move things around when I need to. And you're sort of, I think what you're looking for is somewhere in the middle where you're willing.
I don't want to re-architect. I don't want to re-architect all of Ceph.
So I think the first easy thing would be some sort of explicit PG mapping where you can limit some of the PG stuff moving around. Maybe that'll that might give you like maybe 20% or 30%, maybe more. Or sort of the silo thing that we talked about, where when you deploy big chunks of storage, you create just separate pools and you sort of fill them up and then fill up the next one, because it's sort of like write once and rarely delete type archive data.
Right.
That's another option. There was a suggestion on IRC channel just a moment ago where, that the problem is that your hash distributed storage is spinning up random disks as you have the sort of trickle of data coming in. I mean, the sort of obvious solution there is that you just have it buffered somehow. So you have like a cache tier, even like a Rados cache tier, that's getting all the ingest stuff. And then every once in a while you go and you flush the whole thing. And so you spin up a bunch of racks and you do a bunch of writes, and then you spin it all down again. Which I think is conceptually simple and architecturally simple, as long as you don't architect things so that like it's some stupid thing where you can't power up more than 5% of the drives without blowing your power circuits or something. Which
right. So basically,
limiting.
So basically, you'd be using a cache tier as basically you write things to the cache. It hosts sequential writes, and then it writes all that stuff sequentially out to disks.
Yeah, it's not strictly sequential, but it's a buffer, so you can leave everything powered off on the back end. So this is assuming you have ingest, but you're not reading any of the data.
Right.
And then whenever your cache thing fills up, you power up all the back ends and you do a big flush and you just, push it all out. And your cache is empty again. You power it all down and then you let it fill up over the next couple of days or whatever. So I think that's another model that would work here.
Okay.
I think one last thing that I want to mention. This is mostly for Sam. Back up on the PG-Temp topic. So maybe PG-Temp isn't a tool, or like a policy around how you use PG-Temp isn't a tool. But you'll notice there was a similar query on the email list earlier today about disabling crush and sort of using a different algorithm. I'm wondering if what we want to add in the OST map is an exception mapping similar to PG-Temp that's called like PG-Force, where you can just, if you want to, just leave the crush map empty and just literally enumerate where each PG goes. And so the admin could just say, just force it over there. I don't want it there. And it would do it, right? And then you could have...
Sorry, go ahead.
Sorry, go ahead.
I was going to say the only catch is crush magically handles the failure case.
Yeah.
Force PG,
yeah, so this would not. Like this, you would have to manage it. But I think there are cases where you're like,
I think you're right.
Either like you want to prod at the cluster and like make it do something for some reason that like we aren't contemplating right now, or you literally just want to have like a central thing that's just deciding, it sees the failure and it says, okay, move that piece of data over there. Like you literally want some external agent that's orchestrating all that movement, and you don't want to sort of.
Moreover, if you have that, you don't
the
need
crush gods. If you do that, what?
If you do that, you don't need 100 PGs per OST.
Exactly. Yeah. Right. Or say you are using crush, and it gives you some bell curve of what the utilizations are, and you're literally like, okay, I'm just gonna have this agent that's gonna move 10% of the PGs to make my balance perfect. Right. Yeah. Instead of doing the sort of exceptional case that's whatever. So I think the only caveat there is that I think those mappings need to, in addition to like what the actual desired mapping is, they need to have a priority associated with them. So you can identify like who set the mapping and therefore who's able to change it. Because right now PG-Temp is sort of 100% owned by the OST peering code, and you can't
need it anyway.
As an admin override it.
Code, the OST still need the ability to override the upset.
Exactly. Yeah. Right. Yeah. So anyway, okay. So I think that's another thing that we should do at some point, but another piece of the puzzle that could be used in this context.
Okay.
Let's see. Oh, all right. I got the hot spares thing. I thought was interesting. I don't think we've talked about that before, but I thought that was a good idea too.
Yeah, it's basically a RAID methodology, but that doesn't mean it won't work. So.
Right.
Well, it's trading some capacity for a for a more static mapping. Right?
Yeah.
It means that your recovery is slower because you're bottlenecked on that one disk, but it gives you the static mapping.
Well, sort of. You were going to recover back to that one disk anyway, so your recovery isn't actually.
Never mind. Yeah.
But the data loss window is is the whole time instead of just part of it, right? That's the problem.
Yeah. Yeah. Anyway. Okay.
Are we wrapping this one up, are we? We cover off on everything you wanted?
Yeah, I think so. I got some good notes in the Etherpad.
Cool beans.
Cool.
All right. Well, if that's the case, then I'll get the video flipped here, and we'll do the last one, which should be short.
Excellent.